Just first off, I'd like to introduce Luke from Bureau of Meteorology. Luke has been with the Bureau of Meteorology for 12 years and is currently working in the Agriculture and Water program. His role is to listen to the needs of customers in the agricultural sector and help make their needs reflected in the Bureau's existing products and new services development. Luke recently led a consultation process for the Regional Climate and Weather Guides project, and I think I was involved in that a couple of years ago, and I think Adrian from LLS and a few others to provide feedback into that project with the CSIRO as well, I think. And currently leading customer engagement for new climate services for agriculture program under the Future Drought Fund. So I'll hand it over to you, Luke. Thank you.
Thanks very much, Roger, and thank you for having me. And thanks also for extending the invite to come up and visit in person. But of course, for obvious reasons, that we couldn't make that happen. But I'd be delighted to visit you again another time if we get the chance. Today, I'm going to take you through a few topics of interest from across weather and climate and some of our services that the Bureau offers. I actually can't see the chat for whatever reason. But what we might do is we'll wait. I'll go through my presentation. There'll be plenty of time for questions at the end. So if we hold off with the questions at the end, and I'll go through the chat, or I'll get someone to go through the chat for me.
Yeah, we'll try and fix that now remotely there, Luke, and see what's going on.
That's okay, not a problem. It'll all work out. Now, let me just check that. Is my screen sharing?
Yes.
Yes, it is.
Okay, thank you. Let me just go back to that. I probably just turned it off and now need to go back. Thanks. All right, I'll just go full screen. Okay, so what I like to start with today is just to tell you a little bit about the Bureau's strategy. So we're really all about creating value and impact for all Australians, and there's really two sides to our strategy, and we're all about building products and services that benefit the Australian community, and that's particularly during times of severe weather and emergency services and things like that. And the other side to it is that we like to make sure that we're helping drive competitive advantage for businesses and industries. My role is it's a bit of both. So I work in the agriculture program. Part of my role is to listen to rural communities and farming communities and understand their needs and make sure that our public services meet those needs. And the other side to my role is to understand where we can develop new services to make sure that we continue to drive competitive advantage and make sure that businesses and industries are thriving into the future. And there's probably a little bit of a theme to that today with some of the things I'll go through. This is really the span of information that we work with. So we have a record of Australia's climate that expands over 100 years into the past. We work with observations in the current, right up to the minute and the second in some cases with our weather station network across Australia, and we also tap into global networks of weather observations and satellite information as well. And probably what you know us most for is our forecasts that go out 7 days ahead, weeks, months, and also into the years with our climate projection work that we do in collaboration with a whole range of agencies, including the CSIRO. So we really work across all timescales, and it's really important to use all of that information. It's all relevant, and today's talk will be about showing you a little bit how to use that information a little bit better. So I'm going to talk about some climate context for the region, for the Western Murray region, and then I'll talk about our 7-day weather forecasts, our seasonal outlooks, and a new service that we're developing at the moment under the Future Drought Fund. So let's start with the climate context. So Roger mentioned that a couple of years ago we did a program on behalf of the federal government for the Drought Relief Fund, and that was called the Regional Weather and Climate Guides Project. The idea behind that was to provide, I guess, a snapshot of climate for all of the NRM regions around the country. So in New South Wales, they're the LLS regions. So there's a guide like this for every LLS region, and there's a link there on the slide. And I should also mention that I'll share the slides with Roger and the team later on, and you can all have a copy of those. So don't worry too much about scrambling down web addresses and whatnot. But it was all about a snapshot of the region's climate from 1959 to 2018, and it compared two 30-year periods. And there was a range of topics included in the guides, and they were just 4 pages. And what we did was we travelled around the country, and we asked people about how they'd like us to present climate information and climate statistics in a way that was more meaningful for their decision making in agriculture. So what I'm going to do now is just take you through some of the information that we found, and it's based on the Deniliquin weather station. So one of the things that we had a look at and presented was information on annual rainfall, and we've got the record there that goes back to 1900. And just keep in mind that this is based on work that's a couple of years out of date now. Of course, there's three more years to add to the record, but I will show you our new project at the end that will come full circle back to this. But really, you know, you can see, of course, the natural variability in there, but overall, the rainfall in Deniliquin's been relatively stable over the past 60 years. So there really hasn't been much of a change. That doesn't mean that you get the same amount of rainfall every year. It just means that with natural variation, on average, the average hasn't been changing. That dark squiggly line represents a 10-year running average. And yes, there's definitely some bumps in there, you know, in the 60s and late 70s, early 80s, with some wetter periods, some drier periods in the 40s, but on a whole, fairly stable. And here's just another way of looking at that information. So when we actually broke the record down into 3 parts, so the top 30% being the wettest years, the middle being the average, and the bottom 30% being the dry years, we compared those 2 periods, those 2 30-year periods. And I should say, the reason why we have those 2 30-year periods is because when we travelled around the country, people told us that they were 2 periods of living memory for farming communities. And there was an older generation of farmers who still working on the land today and experienced the 60s, 70s and 80s. And then there's a newer generation of farmers who have got that recent history, recent memory back into the 90s. And so they told us that it would be really relevant for us to compare those 2 periods in the work that we did. So you can see here, really, there's not much change at all in terms of the distribution between wet, average and dry years in the last 60 years. So that just reinforces that rainfall's been fairly stable. When we have a little bit of a closer look, though, beneath annual average rainfall, and this is a chart that shows a comparison between average rainfall by month. So the blue bars represent the period 1959 to 1988, and the orange bars represent the period 1989 to 2018. And so wherever there's a difference in those between the bars actually shows a change between the 2 periods. So interestingly, for Deniliquin, even though the annual average rainfall hasn't really changed, there has been some changes in the monthly rainfall, and 2 of those are, you can see that sort of in April and May, there's been a drop off of that autumn rainfall. And then you've also got the early spring rainfall that's decreased a little bit as well. There's also a bit of a decrease in the summer rainfall as well. So we're talking on average, and again, it doesn't mean that that's what you get every year, but on average over a 30-year period, there's been some changes there. This is how rainfall reliability looks across the Murray region, and I'm sure I'm not telling you anything you don't know here, but it is useful for some context. Rainfall reliability is how much rainfall fluctuates from year to year. And so what you're going is from a scale of, you know, the darker blue areas represent fluctuations from year to year about 10 to 20%, and the red areas are a fluctuation of about 100%. So, you know, for example, if you've got 500 millimetres of average rainfall a year, and if you're in that sort of light blue area, that fluctuates or varies on year by about 30 to 40%. And Deniliquin's sort of in that range of what we would consider to be usually reliable rainfall for winter. And winter, with the blue covering the whole Murray region, is clearly the most reliable rainfall. When you look at the other seasons, certainly to the west for spring and autumn, the rainfall is quite less reliable. So really it can fluctuate between 60, 70% year on year. And Deniliquin sort of sits, in the middle of what we would call unreliable rainfall, fluctuating between 50% each year. That really hasn't changed in the last 60 years, so that's pretty stable. One thing that is important across most of the regions in the southeast of Australia and certainly over at Western in South Australia as well is the autumn break. We defined autumn break as 15 millimetres over 3 days. And this is really just about showing people on average, again, it can change from year to year, of course, but on average, over the last 30 years, the autumn break occurs around about mid to late May around Deniliquin. And what the chart actually shows is that right over in the east, the dark blue areas, it's actually showing how many weeks after the 1st of April the autumn break occurs. So the darker blue areas are a couple of weeks after, and the lighter into the sort of greeny sort of colours represent 5, 6, 7 weeks. All the way over in the west, you can see that the autumn break on average doesn't occur until the 2nd of June. So I'll move to temperature, and this is again based on the temperature station at Deniliquin, and I'm just showing a couple of different variables here. So when we ask about how we can present temperature information, frequently what you hear when people talk about climate change is that the temperatures increased by 1.5 degrees on average across the nation. People told us that wasn't particularly meaningful. So rather than presenting average information, what we did is present the information in terms of how many times it meets a threshold. So the threshold that we've chosen for Deniliquin was 38 degrees. And what we can see there is that, certainly since the 90s, there's a bit of an incline there in the number of days over 38 degrees that occur in a year. So, as an example, what we're saying here is that if on average in the 60s, 70s, 80s, you had maybe 15 to 20 days a year over 38 degrees, there's an increase in that trend. And you can see that in the last 10 or so years, there's been, some years where there's been well above 20 times that 38 degrees has occurred. So that's really about, thinking about whatever it is you do, whether it's your business is based on livestock, whether it's based on cropping, horticulture. We all know that hot days can have stress for animals and for plants. And it's really about knowing that, it means that there's more times of the year or more days in the year that you have to manage that stress. The chart to the right at the top is more relevant to livestock. So that's just showing temperature humidity index, stress for animals, which really mirrors the temperature. Down the bottom, something that's certainly very important for beef and for dairy cattle is the nights, and the nights over 20 degrees Celsius. And again, that's something that's been on the incline since the late 90s. And for Deniliquin, actually, interestingly, there's also been an increase in the days below 0 degrees. That's something that we find generally happens when there's an increase in, drying. And although we haven't seen significant rainfall reductions in Deniliquin, the hotter days and the clear, what causes days below 0 degrees is generally those really clear skies that prevent any sort of cloud cover or whatnot locking a bit of heat in. And that's when you get those days below 0 and days of frost. Here's just a bit of a geographic snapshot of what it's like across the region. So I said before the number of days on average. So again, this is comparing 1959 to 1988. and 1989 to 2018. And for Deniliquin, there's been a jump, not a massive jump, of course, but there's 2 more days per year in that in the recent 30-year period where the temperature's gone above 38 degrees than there was in the previous period, which was 10. And you can see that that pattern is quite similar in the sort of close by regions. Rutherglen's a bit of an exception where there's a bit more, or Rutherglen and Albury, I should say, there's a bit more of a jump up there. But it is consistent across the region. And now just on the other aspect of temperature, which I touched on a moment ago, which was days above zero, or below zero, I should say. This is the potential for frost. So we're showing the same periods. So the blue bars are 1959 to 1988, and the orange bars are 89 to 2018. And we're showing the frost days per week, or I should say the potential for frost. So the way we measure potential for frost is what we know is that 2 degrees on the weather station, which sits a little bit above, a metre or so above the surface, is normally about 0 on the surface. So this is about 0 on the surface. It doesn't actually mean that there was a frost. It doesn't tell us that. And of course, frost is very nuanced by the landscape, but this just shows us generally that where you can see in, I guess, from July, August, September and into October, those orange bars have, just pushed up a bit higher than the blue bars. That actually means that there's been a greater potential for frost in that part of the year in the last 30 years. And on average, there's been 4 more nights per year for the potential for frost in August and September. And we know that that can have impacts on cropping. So I'll finish there with the context, and you can get more information, and there's more information in the climate guides online if you want to drill down a little bit more. And I thought I'd move now to the 7-day weather forecast, which I'm sure many of you use. First, to just dispel a bit of a myth about weather forecasts. The first thing is, as you'd be aware, we've got weather stations all around the country. We've got hundreds, if not thousands of them. The myth is that we forecast our weather based on weather stations, and that if your weather station is hundreds of kilometres away or tens of kilometres away from you, that you're getting less of a less quality forecast than you would if you had a weather station in your backyard. And that's actually not true. So the weather stations are used as an input into our weather models, and those weather models run on a supercomputer. And they are just used to tell us exactly what the planet is doing right now at the time we're about to run the weather model. We use observations not only from Australia, but all over the globe as an input into our weather models. We also use satellite information, and all of that goes into the weather model, and the weather model then gives us the forecast for the coming days. And what it does is it creates what we call a forecast grid. And the forecast grid is every 6 kilometres around the country. That's the resolution of the forecast. The model doesn't go back and give a forecast just for the weather station. It gives it for a 6 kilometre grid everywhere around Australia. And I'll show you in a moment how to access that. The first thing I want to show you, though, is how we present the forecast. And the most important aspect, if you're in agriculture, is, generally speaking, rainfall. That's what most people are interested in. So I really wanted to take you through how we present a rainfall forecast. So this is actually a forecast for today. It's not Deniliquin, I can assure you of that. I had to get something that looked vaguely interesting. Unfortunately, there's no rain forecast today in your part of the world. This is actually over in WA. And if you have a look, so on the left, I've presented how we present it on our website, and then on the right, the exact same information as is presented in our smartphone app. And what I really want you to focus on is the bottom, which says possible rainfall. And in this case, it says 10 to 15 millimetres, and then chance of any rain, and it says 100%. So most people tell me that they think that means there's a 100% chance of receiving 10 to 15 millimetres of rain. And I think personally that is a really logical way to read this statement. However, unfortunately, that's not the correct interpretation of how the Bureau presents its weather information. So I really want to tell you exactly how to interpret this information now. Now, I'm not pretending that it's a great way to present information, and I would love to get your feedback on this at the end of the talk. In fact, I have got a question I want to ask you, which is going to help me to provide that feedback back to the Bureau. But let's get into it. So first, I'm going to start with the bottom line that says chance of any rain, and it says 100%. First thing is that those two lines don't actually relate to each other. So where it says 100%, that's actually referring to the minimum amount of rainfall that a Bureau weather station will capture. And the minimum amount of rainfall that a Bureau weather station will capture is 0.2 millimetres. So chance of any rain means there's a 100% chance of 0.2 millimetres, which we all know is really not a lot of rainfall, not even enough to be considered useful. The top line, which says possible rainfall, refers to a distribution of probability. So the first one, 10 millimetres, is a 50% chance of occurring. So if you flip a coin, you might get 10 millimetres. The next number, 15 millimetres, is a 25% chance of occurring. So if you flip a coin 4 times, 1 out of 4, you've got a chance in getting 15 millimetres. So that's very different odds as opposed to a 100% chance of 10 to 15 millimetres. And so I will share you these slides, and that's the answer there. So the answer is possible rainfall. There's a medium chance, 50%, of at least 10 millimetres, and a low chance, 25%, of at least 15 millimetres, and the chance of rain is there's 100% chance of 0.2 millimetres in a 24-hour period, and a 24-hour period is midnight to midnight. You can get this information on our website. In fact, you can get very detailed information on our website, and it's called METI, and you can type METI into your favourite search engine, or you've got the bom.gov.au/METI there. What you can do in that system is you can go in, and I've just highlighted there, you can go and type in your location. You can type in the name of the town, you can type in lat-long coordinates, you can use any type of coordinates that you like and write that into the system. So you can get the forecast for your property if you like, and just keep in mind, again, it's based on that 6-kilometre grid. And I've also highlighted there, so you'll get a little pop-up when you do that. And I've highlighted there, you can click a button that says see text views for location. And that's where the real detailed information is. So you get a couple of options there, and I'm not pretending that you'll be able to read all of the detail on those images. They're very small. It's just an example, but you can get a breakdown by 3-hourly rainfall. And that's in the daily overview. You can also get 3-hourly forecasts for a whole range of parameters. You can get the 50% chance rainfall, the 25% chance rainfall. There's even a 10% chance of extreme rainfall. You can get air temperatures, feels like, dew point, thunderstorms, wind speed, the whole lot, all broken down by 3 hours. There's also direct links to the nearby radars as well on that page. So moving on to our longer term outlooks, which are our seasonal outlooks. The first thing I should say about a seasonal outlook and everything I'm showing you here today is that we actually use different models for each different product. So the seasonal outlook is based on an entirely different set of models than the 7-day weather forecast is, and they produce different information. The first thing to think about when you want to think about the longer term future, I always remind people, and this goes back to what I said at the start, it's about using a combination of historical, recent and forecast information and packaging that together to give you the context for the decision that you're going to make. So this is the recent rainfall around New South Wales. And so on the left, I'm showing the actual rainfall in millimetres. And just focusing in on Deniliquin, and I know that you're not all from Deniliquin. I just picked that out based on, round about where we're talking, the area we're talking today, but I'm sure you're all distributed amongst the region. But Deniliquin's received between 100 and 200 millimetres in winter this year. And on the right, we're showing deciles, which really just show whether you've received above or below or right on average. And so across that sort of Murray region, it looks like you've received around about your average rainfall for this winter, which I think is good news. But you can tell me otherwise in the chat if it's not. I'd love to hear it. And I'm also not pretending that everyone gets the same rainfall, and it can be vastly different, even kilometres down the road. So this is just a general view, and that's how we produce our information to give people some context. But that's the recent rainfall. And here is the outlook for October to December this year. And the outlook is all about probability. So where you see the darker blue colours, it's actually telling us that there's an increased chance of above average rainfall. And I'm going to talk you through in a little bit more detail what that, well, how you can interpret that and what that actually means. But just take note of the scale on the right. So up the top, you've got those bluey green colours, and the darker blue indicates a higher percentage or a higher chance of getting average rainfall, and down below the sort of red to orangey yellow colours represent a much lower chance of getting your average rainfall. I have also got here, so this is what that looks like for this region that we're talking about today for October and October to December. So you can see what it's really saying here is, you know, both of those maps for the next month and for the 3-month period, and we're talking about the 3-month period being October, November, December, all combined into one. The reason that we do that is because the further you go out with your forecast, it's much harder for them to be accurate. But you can get better accuracy if you talk about a broader period. Now, of course, the problem with that is it doesn't tell you exactly when the rainfall is going to fall in that 3-month period. So you just have to keep that in mind. You can get the breakdown by month for the next month, but you can't get the month just for December. So you kind of have to wait for that to keep an eye on it and wait for it to come out. This does get updated every week. But at the moment, that forecast is saying that there's a pretty good chance, above 70 to 80% chance, or above 70% chance, I should say, of getting wetter than average over the next month and the next 3 months. Here's an analogy, and I cringe at using this, but it's actually very useful. So if we think about a roulette wheel, which I'm showing here, it has 5 red squares and it's got 5 black squares. And so if we were going to put in, if we were going to roll the ball into there, we've got an equal chance of getting red as we do with black. Now, instead of using red and black, the way to think of the seasonal forecast is that there's 5 dry squares and there's 5 wet squares. Now, this is relative to your average. So we say dry if it's less than your average rainfall, and we say wet if it's greater than your average rainfall. Now, if we knew nothing about the future and we didn't have sophisticated weather modelling and climate modelling systems that we do, we would know no better than this. We would only know that there's a 50% chance of things being wetter or a 50% chance of things being drier than where we are going in the future, standing here today. But because of the advances in science and technology, we can do much better than that. And so what the model's actually telling us at the moment is that this is what the roulette wheel looks like. It doesn't mean that we're guaranteed to get wetter than average, and it certainly doesn't mean that we're guaranteed to get drier than average, but it is saying there's a favour, it's favouring the chance of wet more than it is for dry. And that's how you should interpret the forecast. So if I just go, I'm just going to click back and go back and see and just show you again. So remember on the scale on the right where you've got the blue colours, and then you've got at the bottom the red colours. What this scale and what this map is showing here for this forecast is that roulette wheel on the far right with the 7 wet squares and the 3 dry squares, that's the current situation for the forecast over the next month and the next 3 months. There is another way to look at this information that you can get on our website, and I will promise to show you that in a moment. And it can be a bit more useful to look at it this way than just thinking about above and below your average. So for Deniliquin, between October and December, the average rainfall is 88 millimetres. And this chart is showing a range of volumes of rainfall and giving the probability, the chance of exceeding that. So there's a really high chance, very close to 100%, that you would receive 25 millimetres or even 50 millimetres over the next 3 months. And then you can see that those volumes decrease from there. And the average rainfall has a 79% chance of occurring. And then you go 100 mil around about 75%, just a little bit less, 150 mil, 50% chance, 200 mil, less than 25% chance. So you can look at this and you can say to yourself, well, all right, well, you know, what do I really need to finish off the season, or what do I really need now going ahead in spring to get that pasture growth? You know, if you said to me, well, I really need 200 mil to make a decent season here, I'd probably say, well, that's fairly unlikely that that's going to happen. You know, have a think about more what's the likely scenario, what the more likely scenarios are of occurring here. And that might be a much better place to think about what your planning might look like. So this is the Climate Outlooks portal. Again, just like the Med-Eye portal, you can go in, you can type in your location, and you can get that little pop-up on the screen that shows you the chart that I just showed you there. There's also a range of time steps. So you can get this type of forecast for next week, next month, the next 3 months. It has rainfall. It also has maximum and minimum temperature. There is a monthly climate and water outlook video that describes this in great detail. It comes out monthly. You can download that online and on YouTube. When I say great detail, I should say it is a climatologist talking, but they talk more broadly about the continent. It won't give you the detail for your local area. You will have to come into the portal to do that. But there is also quarterly webinars that the Bureau offers to the public, and anyone can sign up and dial into those, and that gives you direct access to our climate scientists who can answer all the questions you have. So you're very welcome to attend those. And there's one, I think there might have just been one, and there'll be another one later on in the year. So I'm going to finish now, and I hope I'm on time, with talking about climate services for agriculture. So I started off talking about the climate guides, which was setting the scene with context. I then talked about the sort of near-term weather forecasting, then into the longer-term seasonal outlooks, and I'm going to finish with even longer-term, which we call climate services for agriculture. So this is a future drought fund project which the federal government, the Department of Agriculture, Water and Environment have invested over $10 million in. And what they're asking us to do is create a platform, an online platform that is going to present firstly the digital version of the climate guides. So you can come in and you can type in your location and you can get that climate guide type of information for your location. And it's also going to allow you to select some more commodity specific information. And so this is just the prototype here. So I should say this is absolutely a prototype. It is a draft for comment, and we're really keen to get feedback. We're trying to do some things differently this time around. Often you probably know that frequently governments and government departments, we can be guilty of spending lots of money and building something without actually asking for feedback. So we're really turning that around this time, and we're asking for feedback as we go. So I'm not pretending for a second that this is what the final product will look like, and we are going to be spending a couple of years working on this. The prototype is live and publicly available, and there's the link there, and there's a username and password. And again, you'll have a copy of these slides to go to that later if you like. But the dashboard at the moment, what it presents is the historical climate, the current climate. So that's a little bit like what I showed you with the climate guides. But this time what we're adding is the future projections. And I think Catherine will probably talk a little bit more about future projections, certainly than I will, in her presentation that comes up next. But this is where we'll start to put some information about what the future to 2030, 2050, etc. looks like. And again, what we're trying to do here is present information that's relevant for decision making. So we really do want to get people's feedback on this platform certainly over the next 6 to 12 months and beyond that as well. Coming next in the platform is that the next version, which will be released in December, is going to have more commodity specific information in the dashboard. At the moment, we've only got a couple, so actually I should just go back. There's a little drop down list there that you can then select your own commodity. And so what we're doing at the moment is trying to understand, what commodities do people want to see in there? And then if they want to see that commodity in there, what type of information do you want to see across the dashboard that's relevant for you? We're going to be adding seasonal outlooks. We're not just going to add the seasonal outlooks exactly the same way that they're presented on the Bureau's website. We've done some research behind that, and we understand that agriculture has different needs for how they'd like to see that information presented. And certainly if you have any feedback on that, I'd love to hear it in the question time. And we're also going to be releasing that as a new mobile design. So at the moment, it's just in a desktop prototype format, but we know that mobile devices are heavily used in agriculture and the whole world, frankly. So we'll be designing a new interface that works on a mobile device. But this is just the beginning. So we are seeking your input. So any farmers or advisors, we'd love you to register for co-design activities. The co-design activities include social science interviews, user experience and concept testing. Those sorts of things are one-on-one with some of our designers and our social scientists. They're completely covered by privacy and anonymous. None of that information is passed on. They probably need your time for about an hour, and that's on the phone or in front of the computer. And if you're interested, please do let me know. So we'd love you to be part of co-design activities. There are other feedback mechanisms. You can always give feedback directly to me at agriculture@bom.gov.au, and there is an online feedback form in the prototype. So there's a real opportunity here to give you feedback and help us co-design the new service. And that is the end of my presentation. And if you would like to get in touch and you have any questions that we don't get to cover today, please do email agriculture@bom.gov.au, and I will stop sharing and show my face, and I would love to hear your questions. And I apologise, I can't see the chat, but hopefully someone can.
I'll just say something to start with, Kath. It's Roger here, Luke. That was a great presentation, thank you. And look, I think, you really get co-design. I can see that, it's one thing that we love, that process from a community. You were here a couple of years ago, starting off a process, did various iterations, engaged lots of people from councils, farmers, farmer representative boards, Landcare, LLS. There was an invite put out to everybody, and it was a process of collaboration, collecting all of that data and really taking on board the feedback from people into that finished product, and still seeking co-design information. And yeah, I think that's a learning for a lot of government agencies. that process. I think it's been terrific. So that was just my feedback. Yeah. Is there any other questions from people?
Just mentioned that.
Oh, and we've got a poll up now. Yeah, you might want to go through that week. Yeah.
Oh yeah, okay. If you've got the poll up, so I did have a couple of questions, and I'll just explain that. So what I'd really like to know is, with the weather forecast information and with the seasonal outlooks, there's two questions there, and they're just straight yes/no answers. And I would love to know if you knew how to interpret that information before today's presentation. If I didn't show you anything new, click yes. And if I did show you something new that you didn't know, click no. And the reason I ask is it's not to test you, but rather this is how I can quantify feedback back and pass this back to the Bureau to say, to give an indication of where we might need to improve our presentation. So if you didn't understand it, it's not testing you, please do put that you didn't understand it, and I can take that metric right back with me and have those conversations internally.
Results there, Luke, on your screen coming up.
No, I can't, unfortunately.
We can see it. I don't know if can everybody else see the
I can't see comments I can't
Yes, I can see.
or see comments. I don't know why. I've never experienced that actually.
Okay. Yeah, well, we've got 8 responses, 87% no, and 12% have said yes so far.
So that's for the second one, for the second question.
Oh, that's for the second question.
So,
Right, so a scroll up. We had for the first question, we just had 4 responses. 75% no and 25% yes.
Thanks everyone for filling those out. We appreciate that. And that, just to let you know, that reflects generally the majority. So I have asked that question to several hundred, if not thousands of farmers around the country, and that's very consistent result. So, you know, we are trying to listen, and we are responding to your feedback, and we are working behind the scenes to make sure that we continue to improve our product offering from you and that you can get the most value from it.
does David have a question?
If anyone got a question, you might want to personally put your hand up on the or go on the chat function. David, did you have a question?
I'm just saying that there's a long. I'm not sure if they're hearing.
We can hear David. Yes.
Yes. We're just looking at the longitudinal perspective. Looking at the Aboriginal values that are supported by all this climate, and understanding we've just finished meeting with the a whole range of people looking at Yanko Creek and what they're doing, but it would be interesting to look at the intersection of Aboriginal weather patterns with the Bureau's weather patterns.
I couldn't agree more. I think there's a lot that we could learn from Indigenous weather knowledge. We do, so the Bureau does have a program of Indigenous weather knowledge, and we do present calendars online, and we do have an engagement program with Indigenous country around the nation. So that's certainly something that we're building up. It's not, of course, we have to keep in mind that it's not a straightforward exercise, and it does in part, in a big way, depend on the engagement that people would like us to have with them. So, but we do definitely have a diversity and inclusion program at the Bureau, and we do have an Indigenous weather calendar that you can type that into the search engine. You can have a look at that as well, and we're continuing to add different communities' knowledge to that every year.
From my perspective, I'll just put my video camera on. Just while people might be coming up with questions. Yeah, I didn't know that, you know, a 10 to 15 mil rainfall percentage. I didn't know it worked that way, 100%. I took it as being, you know, if it was a 70% chance between 10 to 15 mils, it would have said 70%. Yeah, but not knowing it was 0.2 mil, that was definitely new information for me. And I thought it was interesting that the range went from a 50% chance starting at 10 millimetres as an example, and 25% chance of 15. And I wonder why it didn't go from 25% chance through to 25% chance with 50 in the middle. So like, but I suppose, and that comes down to your chance of seeing that to the 6 kilometre radius, not whether it's a delinquent figure. If we're in Barham 90 kilometres away, it comes down to 6 kilometres. So Denny would see something different to us in that.
Correct. That's exactly right. That's how it works. And thanks for the feedback. That is some reporting the 25% chance. It does make sense, and that's actually something that we are considering. We do have some improvements to the website that are occurring in the background at the moment, and they're most likely to be released in the next year or so. And that's definitely one of the options that we're thinking about. It's interesting. It is interesting because if you said to me, the Bureau gets the rainfall forecast wrong half of the time, that would be right, because we're producing the 50% chance, right? And so if we were accurate with that, we would actually expect to only get it right 50% of the time. So yeah, we're kind of, it's funny because we're stacking the odds against ourselves with people's interpretation of our forecast. But I do think that we are seriously considering adding the 25%. I think just to give you a bit of background, I think the original thinking behind not presenting it was that generally the 25% is going to be a very low number, and if not zero. But the feedback we've heard is, well, we'd still like to see the 25%, you know, what the 75% chance of occurring is, because, you know, it's just about being open and transparent and showing the full range of possibilities. That's what people would like to see.
Yeah. I had another, it's an observation, it's not based on fact, it's anecdotal, but and maybe you've got a new computer system, it might have changed the data too, and there's upgrades, but whether a La Nina year, I seem to think that you get it pretty right, even though it's 50% chance, that bottom figure of say 10 mil, if you say 10 mil, we generally get about that 10 mil, but in a El Nino, a drier period, I think it's a lot more inaccurate. With that, I don't know if you have statistics on that, but that's just an observation.
We don't. So the problem with there's a couple of reasons why you might be observing that. One is that when a La Nina occurs, there is an increased chance of receiving more rainfall, above average rainfall in Southeast Australia. So it's possibly just an artifact of the fact that there's actually more rain falling. The other side to that is, and so in terms of analysis, we do have statistics, but we don't tend to release statistics when it comes to you know, how accurate was the forecast when it was a La Nina year versus an El Nino year, etc. And the reason is because they don't happen that often. And so when those phenomena don't occur that often, it makes it much harder for us to give a pragmatic view of what might actually be happening. And so you can easily jump to conclusions based on not enough data, and that can be a little bit dangerous. The rainfall forecast is the way that it's forecast. It does predict across a broad area. So predicting rainfall, and as I'm sure you're all aware, rainfall is highly variable, even across just kilometres. So, you know, some of you might get 15 mil, and in the same event, your neighbour down the road got 5 or got 3 or got nothing, right? So when we forecast, it does forecast, generally speaking, for that range across an area. But the reality is, when it does happen, it doesn't happen exactly like that forecast across a range. It will happen somewhere. So that 10 to 15 mil I showed you, that's going to happen somewhere in Perth today, but it won't happen everywhere. And so that, when you have that type of forecast and in a drier year, you may also find that might be why you're observing that. So yeah, that part of the variability is a lot of variability in forecasting rainfall, and then just the way some of those broader drivers work can sometimes you know, lead you to think. I'm not saying your observations are not right; they absolutely could be, but you do need a lot of data to be able to, I guess, prove or otherwise whether or not that's actually occurring.
Yeah. Okay. Thanks, Luke. Have we got any other questions? Okay, we're running on time.